Hi everyone, welcome to another session of our short video series. In this video, you'll learn about how to add vector quantities. Before we start, you may like to know what is the purpose of adding vector. We add vectors to get the resultant vector, which is a single vector that gives the combined effects of all vectors. If you run 3 kilometers yesterday and 4 kilometers today, you ran a total of 7 kilometers. We add scalars as we do with numbers. However, vectors, because of their direction, cannot be simply added together unless they are in the same direction. For example, if a 3 Newton force and a 4 Newton force acts on a body at the same time, what would be the magnitude of the force experienced by the body? Which direction would the body move? Yeah, well, guess what? There are an infinite number of possible answers to this question. In this slide, we'll only show you 3 possibilities. The first one is when 2 forces are in the same direction. The resultant is a 7 Newton's force. In fact, this is the case when the resultant force is maximum. Second possibility is when the 2 forces are in opposite direction. In this case, the resultant force is 1 Newton in the same direction as the 4 Newton force. This is the case when the resultant force is minimum. The third possibility is when the 2 forces are perpendicular to each other. But wait, there's a whole host of possibilities if these 2 forces are at any angle to each other. Therefore, we have an infinite number of possible answers. In general, there are 2 methods of performing vector addition. The first is the head-to-tail method. Suppose you have 3 vectors, as shown in the diagram. You will join the tail of the second vector to the head of the first vector, and the tail of the third vector to the head of the second vector. If you have more than 3 vectors, just continue the process. The resultant vector is obtained by joining the tail of the first vector to the head of the last vector. And in our example, the last vector is red color resultant vector. If the diagram is drawn to scale, the resultant vector can be found using a ruler. The length represents the magnitude, and the direction can be measured using a protractor. We can also make use of sine rule, cosine rule, or any other trigonometric functions to solve such problems, especially if the vectors form a triangle. In this example, we first make use of the head-to-tail method. Since the vector forms a triangle, we can apply cosine rule to find the magnitude of the resultant vector, and then use sine rule to find the direction of the resultant vector. The second method is the component method. In this method, we resolve all forces that we wish to add into their x and y directions. Then we add all the x components and y components together separately. The resultant vectors can be found using Pythagorean theorem and its direction using the tangent function. Let's find out how to resolve vectors into their x and y components. Suppose you have a force of 100 newtons acting 60 degrees to the horizontal x-axis. This 100 newtons force is made of 2 components as shown in the diagram. Since this is a right angle triangle, we can apply the rules of trigonometry. The x component is 100 cosine 60 degrees, and the y component is 100 sine 60 degrees. It is important to note that by resolving a vector into its x and y component, the vector no longer exists. Likewise, if we combine the x and y components to obtain the resultant vector, then the component vectors do not exist anymore. Let's take a look at an example. In this example, we first resolve 40 newtons and 75 newtons forces into their x and y components. Then we add the x components of the resultant force and the y component of the resultant force. In the next step, we make use of Pythagorean theorem to find the magnitude of the resultant force, and the direction can be found using the tangent formula. Let's take a look at another example, which involves 3 forces rather than 2. Nevertheless, the method is exactly the same. The 8 Newton force is in the negative y direction, and its x components is 0. The 10 Newton force is in the positive x direction, and its y component is 0. The 12 Newton force can be resolved into its x and y components. The x component of the resultant force is found by adding the x components together. Using the same method, you can find the y component of the resultant force. The magnitude of the resultant force can be found from Pythagorean theorem, and the direction using the tangent function. That's all for this session on addition of vectors. Be sure to check out more of our videos.